All right, here we go. Some more practice by solving through graphing. Again, the graphing is just a tool to help us solve. It's not the solution itself, just a way to get there. Notice this one's a little bit different. Now we're looking for numbers that are greater or equal to 0. And we're going to go through the same process. We're going to pretend for a bit that it's equal to y. Let's graph it and see what would happen if it was equal to y. This one's been factored for us already, and so that's kind of nice. We still want to factor this first part again, though, because that's going to be x plus 1, x minus 1. So x plus 1 and x minus 1 as our first ones. However, the second part has been factored fully, and so we have a double root. It's x minus 4 and x minus 4, and all that greater than or equal to 0. So our roots here are going to be negative 1, 1, 4, and 4. So I'm going to come over, negative 1 is a root, positive 1 is a root, 2, 3, and 4 is a double root. All right, and now if we were to multiply this all out, our leading coefficient would be negative, so we need to start at negative infinity here and head on up. Remember, single root, double root, so we're going to head on up, turn around, head back through, turn around, head up, and bounce off of that last root. We're a fourth degree polynomial right now, and so make sure that we our end behaviors, that our two ends are going the same direction. So here's our graph. Now let's use that to figure out when x values would give us a positive output or equal to 0. Now if we go right at negative 1, everything left of negative 1 gives us a negative. That's not what we're looking for. However, right at x equals negative 1, we get 0. If I were to plug in negative 1 here, I get negative 1 squared. That's 1. 1 minus 1 is 0. And then I can not even worry about the rest of this because 0 times all of it gives me 0, which is equal to 0. So my solution starts at negative 1. And where it's x is going to be greater than or equal to negative 1. And it continues to be positive until we get to positive 1. So this is a root of 1, 0, and here we got negative 1, 0. We'll add those in. And this one was 4, 0. Okay. So it continues to be positive until we get to 1 again. And it's or equal to because it's or equal to here on the graph. If I plugged in 1, I get 0. And so those are some of my solutions. So solution. We got negative 1 is less than x, or less than or equal to x, which is less than or equal to 1, and equal to less than or equal to, sorry, I'm mumbling that all over the place. Our solution is negative 1 is less than or equal to x, and less than or equal to 1. So here are some positive solutions. We want these. These are good. Once we get past 1, though, from 1 to 4, we're again in a negative output. We're not looking for those right now. We're looking for positive numbers. And though we're going to bounce off at 4, x can also be equal to 4. That's going to be a solution. We're going to have a point right there. If you were to graph our solution on a number line, this is another thing we should be able to do. If it said to graph your solution, we'd have 0 somewhere in the middle, negative numbers, positive numbers, and we would have solutions at negative 1 to positive 1, 1. Go ahead and do those in red. They would be included. They're solid circles. And all the numbers from negative 1 to positive 1 are solutions for us. We also have a solution right at 4, just a single point. 4 is also a solution. There you go. Hope that helps.